Hey guys, so today we're going to be looking at how to simplify radical expressions. And we're going to look at 4 quick examples just to go over how to do this. So our first example is we have the square root of x to the 8th power. Okay, and so whenever I go ahead and look at this, I always remember the rule that we should know before this, which is a to the m over n power is equal to the nth root of a to the mth power. So really, when I see this square root here, I recognize that this is taking the square root, which is the second root. So this is really to the second root of x to the 8th power. So really, I can think of this as, if I'm using my example up here, whatever the root is, that's going to be the denominator of my exponent, so that's going to be 2, and then my 8 is going to be on top. So the 2 goes to the denominator, the 8 goes to the top. So this is really just x to the 8 over 2, which is just x to the 4th, right? But there's one more thing. Since this is under a square root, what can a square root be? We first and foremost have to say that this must be positive. Because if I'm taking the square root of something, for example, let's say the square root of negative 2. Well, let's say the square root of negative 4. If I think about what two numbers multiply by themselves to get me negative 4, well, it can't be negative 2 and negative 2, and it can't be positive 2 and positive 2. So this would get me an imaginary solution if I went ahead and solved this. So we're going to stay away from imaginary numbers now. We're just going to give our answers as real solutions. And so what we have to do then to make this answer plausible, in order to make this positive, since it has to be positive, the function we are going to write it as is the absolute value of x to the 4th power. This ensures that this will always be positive, because that's what our absolute value does. So from the beginning of our problem, we said that this must be positive because it's under a square root. And so now writing the absolute value, it makes it always positive. So I'm going to put this on the bottom of the screen. We're going to continue with this for the next few examples. So let's go ahead and put it there. All right. Now notice this says even root. Why does it say even? Well, let's think about if I were to take an odd root, like the third root of, let's say, negative 8. If I have a third root, an odd numbered root, like 3 or 5, this could be, 5, the fifth root of negative 8, it could be the seventh root of negative 8, whatever it is, this could be a negative number. It can be negative because it's an odd root. Because think about it, what numbers multiplied by itself 3 times gets me negative 8? Well, I could write negative 2 times negative 2 times negative 2. So in this situation, my answer can be negative 2. It doesn't have to be the absolute value of that. So we're going to go ahead and we're going to look at an example that has an odd root in this problem. So let's go ahead and green do this problem. Since this is an odd root, our rule down here doesn't apply. Remember, it has to be an even root for it to be an absolute value as my final answer. So I'm going to go ahead and I'm going to write this. And remember, we know that a to the m over nth power is the same as the nth root of a to the mth power. So what I can do is I can write it from this side of the equation into my a to the m over n power. And you'll see why that's simpler, because if 3 is n and 9 is m, that means that if I write it as a to the m over n, that's x to the, what is n? Well, n is 9 over n, which is 3. And I know what 9 divided by 3 is. It's just 3. So x to the third power. So my answer is just x to the third power, not an absolute value, because it's an odd root. If this was a fourth root or a sixth root or any even root, my final answer would be an absolute value. But since it's an odd root, it just is the answer that it is. Okay, so let's look at a couple more examples just to demonstrate this. One more even and one more odd. All right, so here we have the square root of 256 times x to the 16th power. And so remember, this is an even root. We are taking the second root of 256 times x to the 16th. So since this is an even root, we should expect our answer to be an absolute value. So since it's an even root, it has to be a positive answer because anything under an even root radical must be positive. So our final answer must be positive when we evaluate this. So now we're going to think about this. What is a square root really? Well, a square root is just, instead of writing it as the square root of 256 x to the 16th, it's just 256 x to the 16th to the 1/2 power. And so now I can use my exponent rules. I can multiply this in. Remember, I have an exponent rule that says a times b to the nth power is just a to the n times b to the n. So I can take this square root to both of these numbers, and this becomes 256 to the 1/2 power times x to the 16th to the 1/2 power. And so now when I use my my power of products rule, or my product of powers rule, so now when I use my exponent laws here, I also have a law that says a to the m to the nth power is equal to a to the m times n. So 256 to the 1/2 power, well, and this is where a calculator comes in handy. If you don't happen to know what the square root of 256 is, it is 16. And x to the 16th power to the 1/2 power, if I multiply those exponents together like my law says here, then this is just x to the 8th power. And remember, since it is an even root that I'm dealing with, I have to write my answer as an absolute value because it must be positive, because if I have a negative answer, it wouldn't work in the domain of this function. So it cannot be negative, which is why we write an absolute value function. Okay, so this one now, what is the root of this? Is it even or odd? I'll give you a second to look at it. This would be a fifth root, which means it is an odd root radical expression. So this is not going to require us to write our final answer as an absolute value. So we are just going to distribute this here. So a fifth root we know is just something to the 1/5 power. So I'm going to rewrite this exponent. Instead of writing it to the fifth root, I'm going to write it to the 1/5 power. That's the same thing. So now we're going to distribute this evenly. So this is negative 1024 to the 1/5 power. And when I distribute this and multiply it, I get x to the first power. Okay, so now take out your calculator and find the fifth root of negative 124, or raise negative 1024 to the 1/5 power. And so the fifth root of negative 1024 is negative 4. And then I am left with just x to the first power, which is just x. And again, since it's not an even root radical expression, the answer is just what it is. It doesn't have to be positive, so we don't have to put the absolute value symbols on this. One quick thing. So if you're like me, and you're doing an online assignment, let's say on a class like IXL. That's an online assignment that will want you to enter in answers, and it has to be super precise. So if you get an answer that looks something like this, when you're watching my video and you recognize, oh, I had an even root, so I have to make it the absolute value. So if you got the absolute value of x to the fourth power, one thing just to point out for IXL is I can actually just write this as x to the fourth power. Because if you think about numbers that you plug in here, since this is an even number as its exponent, this right here, no matter what I plug into it, is going to give me a positive answer. So if I plug in a -1, for example, -1 to the fourth power, that's going to get me +1, and so the absolute value of +1 would just be 1. Right? So no matter what I plug in here, this is going to get me a positive answer. So in other words, this absolute value symbol that I have here is actually not needed. We can actually make our answer just x to the fourth. So if you're using IXL or some other online answer and it is telling you that the absolute value is not what it's wanting, even though my video was telling you to do the absolute value symbol, consider maybe you had an even exponent in your final answer. And if that's the case, any even number as an exponent will always give you a positive answer, so you don't need the absolute value symbol. However, when you come over here, my final answer as the absolute value of x to the third, this is the complete answer because my x to the third is an odd power. So if I plug in a negative number here, like let's say -1, -1 to the third power is -1. So the absolute value of -1 would get you +1. So this absolute value function is necessary here. And make sure you guys consider this when you're typing stuff into online homework assignments like IXL. Okay, so here's a 4 simple examples of how to simplify some radical expressions. And I hope this helps. Let me know if there's anything else I can do to clear this up, and have a nice day.